Okay, good afternoon, everyone. Welcome to today's class. In the last class, we briefly introduced the basic representation method for the data structure for the binary tree, right? How to use the formula-based representation method to represent a binary tree. Actually, the reason we can use an array to represent a binary tree because we use the property 4, use the complete binary tree idea, right? So based on this idea, we can use the array, the linear structure, to represent a hierarchical data structure, right? But the advantage is that it is very easy to understand, and we don't need additional information to store the address information for the next node or for the children node, parent node, right? We just calculate the index, then we can locate the current node, parent node, or the children's node, right? But the disadvantage is also very obvious because as you can see from the figures or examples, even we only want to store a very small binary tree, such as this one, right? It only contains 3 nodes. But because we need to reorganize this binary tree into a complete binary tree, then we can store it. Because of this, we have to use or we have to claim a much larger space to store this only 3 node binary tree, right? So it means we will waste a lot of space. So the space complexity is very high. And this is the most difficult part. And this is the most disadvantage, right, for the formula-based representation. And because of this, for the another representation method called the link-based representation method, right? This is a more popular way to represent the binary tree, right? We just use a pointer or use the links to represent the binary tree. So in this idea, for each node, we have 2 fields. One field is the data. One field is the data. Another field is the binary another field is the pointer where for the left child and the right child address, right? So it's more like in this way. So given a node, we always had 2 fields. The first field is data. Store the data for each node, right? And we also have 2 pointers pointed to the left child and the right child, right? So this is LDR, right? And based on this representation method, we can easily define who is the child for the current node, right? And the disadvantage is also very clear. It is not easy to find who is the parent node for the current node, right? Because we do not have any direct we don't have any pointer directly pointed to the parent node, right? So this is the disadvantage. And based on these ideas, we can organize or we can claim the representation method, right? We can define it. So this is the binary tree node. In the binary tree node, you can find that, okay, first we should have the data field, right? And also we should have the pointer field, right? In the pointer field, we have 2 pointers. One is pointed to the left tree, another one is pointed to the right tree, right? We have 2 pointers. And in addition to the member variables, we also need to define a lot of functions, right? Such as how to claim or how to create a node, how to give the web, how to visit, and how to use the different functions to traverse all the data, right? And of course, we need to define a lot of operations for the node, right? But here we will mention some of the most important functions, so such as how to determine the height for a given tree, right? What is the height? And we want to define how many nodes we have in a binary tree. And sometimes we need to copy the binary tree. And sometimes we may want to display, and sometimes we want to make a judgment whether these two binary trees are identical or not, right? Okay, finally, we want to delete the binary tree, right? All these operations, actually, they are depend on a very important operation called the traversal. Traversal. This is a very important operation, right? And in this operation called the traversal, each element will only be visited for one time, right? So please remember, in the traversal operations, each node will always be visited and only visited exactly one time, right? Only visited only one time, right? So because of this, so the traversal algorithm is the most important algorithm for the binary tree, And in this class, we will spend most of the time to discuss about the traversal algorithm, right? And this is the important part. Okay,